In this video, we're looking at the math portion of the ACT. I want to briefly go over the 7 aspects that are covered on the exam, the 7 categories of mathematics that are used in that you need to prepare for in taking the ACT. The first is pre-algebra. So these are concepts you might have learned in 6th, 7th, or 8th grade. Actually 4th, 5th, 6th, or 7th grade, depending on when you started working on fractions. So we have pre-algebra, we have elementary algebra, and then we have intermediate algebra. So you're looking at algebra 1 and algebra 2 materials here. And then we have geometry, plane geometry. We also have coordinate geometry, and trigonometry. And finally, we have statistics and probability. So those are the 7 sections. And you can feel free to always pause the video and highlight on any section you need to focus on. So there's 7 sections. Coming into the preparation course, I don't know where everybody is right away, and so this is a good video that will take you through the concepts. And again, you can move the cursor ahead if you need to, or you can pause and focus. So these are the 7 sections that we're going to look at, and I'm going to start with pre-algebra. This is a good review. If you want to zoom in on any of these concepts, I also try to provide more videos in each of the week modules. So like week 1, there's a few videos that I've uploaded from Vimeo. You can use that to highlight on pre-algebra, or you can use the videos from week 2 to do that. So let's try our best to see if we can use week 1, these 2 concepts together. These 2 fields, pre-algebra and elementary algebra. And then week 2, you can focus on intermediate algebra, and then you have plane geometry, coordinate geometry, trigonometry, and statistics and probability. So this is one way you can tackle this exam, is to take your 6-week plan, and you basically spend extra time each week on each of these modules. At the end of 6 weeks, the goal is you should be comfortable with all the concepts on the exam. Please don't hesitate to email if you need more practice or if you need more resources for any one of these concepts on the math section. I highly recommend that we work as hard as we can to score as high as possible in the math, and that's because of its objectivity. You don't have to be concerned about questions that ask, which of these sentences is best placed here or there. Now, that would be in the English section. It's not as objective, because sometimes people choose A and they think it makes the most sense, but the answer is B. See, with math, we have formulas, we have a certain pattern we're trying to get after, and that's it. And I'm not saying that English doesn't have objectivity, but I'm just saying the math portion of the math test has a higher level of objectivity, of just using formulas or using reasoning to get to the answer. There are ways to raise your score in the English and reading as well, and we'll talk about that, and then also on the science. So welcome again, and let's dive into the math pre-algebra. So we have pre-algebra now. We're zooming in. So imagine you clicked on imagine you clicked on pre-algebra, and now you're going to see the types of topics. So let me just start from the very important question of just numbers as a whole. What are the different types of numbers, and do we understand what integers are, what is rational, what is irrational? Let's talk about those things, and then we'll come back and go into factors of numbers, prime numbers, and so on and so forth. So numbers. When one of the examples I've seen that makes the most sense with making sense of numbers is to recognize that we have natural numbers, right? Natural numbers will be numbers like 1, 2, 3. Think about how old somebody is, right? That's like natural numbers. Then when you put that in a circle or in an oval of its own, there's another category above natural. So it includes all natural numbers plus one other number, and that's whole numbers. So whole numbers are numbers like 0, 1, 2, 3. So again, we had natural numbers from 1, 2, 3 to infinity. We have whole numbers 0, 1, 2, 3 to infinity. And then the next level up is we have something called integers. And this is important because there are rules that govern how integers ought to work. So then we have integers. The integers would be negative numbers and positive numbers, and it includes 0. So think of negative numbers, 0, and then positive numbers. Examples will be, again, -5, -4, -3, -2, -1, 0, 1, 2, 3, all the way to infinity. And this is coming from negative infinity. So integers would be negative numbers, positive numbers, and also 0. The next category up from integers would actually be rational numbers. So if I can move the numbers here out of the way, and we can say there's a category here, and we're going to call that rational numbers. So everything, all these, belong to rational numbers. So rational numbers are basically numbers that can be written in the form of a over b. We're talking about a terminating decimal. We're talking about, so think about all these integers. -2 over 1, that's a rational number. Think of 4 over 5, that's a rational number. Think of 1 over 3, it has a terminating decimal. That's what it has, a pattern to it. That's a rational number. So we have rational numbers contain all the other categories that have been described. However, there's another group of numbers here that we're going to put off to the side, and this one is called irrational numbers. So over here to the side, we're going to call it irrational numbers. And irrational numbers would be things like pi, e, which is using compound interest, the square root of a prime number. If you take the square root of a prime number, that answer is irrational. So we have rational numbers, all these on the right side. We have them on the right side, and we have irrational numbers on the left side here. All of these combined belong to one group though, and that is real numbers. So all that I've been showing you here belong to real numbers. So I'm just going to rewrite that clearly. So we have real numbers. All of these belong to real numbers. Very good. Real numbers. So remember, real numbers include rational numbers, and they also include irrational numbers. Rational numbers are any numbers that can be written as a ratio of something over something. So that's what rational numbers are. And then irrational numbers are numbers that do not have a terminating decimal, and our examples are pi, e squared of 2, squared of 3. Notice that pi goes on and on. We've calculated it now, maybe let's say to about 1 trillion digits on certain computer systems. But that is something to keep in mind, is that those numbers have no end in terms of a pattern to their end. So that's the beginning of pre-algebra discussions, is knowing what these kinds of numbers are. So let me just leave you with some rules of integers that are good to remember. So rules as far as arithmetic rules with integers. So arithmetic rules with integers. So when you have, for example, -2 times -3, that's +6. -2 times +3 is -6. -3 times 2 is -6. And 2 times 3 is 6. So we know that when you have the same sign, then you will get a positive product. When you have different signs, you will get negative as your answer. So that is something to keep in mind with rules of working with integers. When you multiply two integers together, you get, if they're both positive, you get a positive answer. If they're both negative, you also get a positive answer. The other thing that's very important to understand with integers is how they operate in terms of adding and subtracting. Now, we have a resource, and if you look up Tyler Wallace algebra in Google, just a Google search of Tyler Wallace algebra, there's a free textbook, and if you go to 0.1, that is the focus, is on integers. Again, if you need a reminder, if there's any topic that you ever need a refresher on, just let us know and we'll provide you with examples and so on. So in that book, there's a focus on examples are given of integers, how they work, and so on. But what I want to do now is I want to talk about what happens when you have 5 minus 3. Well, we know that that's 2. But what if it's -5 plus 3? We'll come back to that situation. And what if it is -5 minus 3? And what if it is -3 plus 5? So let's look at these situations. This one over here, you're starting with -5 and you're adding 3. So independently of the sign, 5 is a bigger number than 3. So, but if 5 is the negative number and we're adding 3, that means our final answer needs to be a negative because the 3 is not sufficient to bring the negative 5 into the positive range. So that's how we get negative 2 for that answer. The next one, we have negative 5, right? So imagine you have borrowed $5 and now you need to borrow $3 more. Well, you're going to owe negative 8 now. You're going to owe $8. So you're going to owe more than you did initially. And then we have negative 3 plus 5. That is actually the same thing as that. So those two are the same because we can rewrite that as 5 minus 3, which is also 2. As part of this course, one of the things that you get access to is a book that we've written called Tools for Mastering Mathematics. I want to encourage you to read that, at least look at the part 2 of the book. If you do have the time and the opportunity, I highly recommend the first part of the book as well. But this book is in PDF format, and you can, again, feel free to read it. Let me know what you think about the concepts that I discussed. But in the first part of the book, it talks about the nature of mathematics. What is mathematics and how does it work? And how do you become very good at mathematics? That's what the first part of the book talks about. And the second part of the book focuses on concepts that we should remember as we proceed throughout our study of mathematics. For example, and this is why I bring this up, properties of real numbers. So we talked about classification of real numbers, the fact that there's integers, rational numbers, irrational numbers. We've talked about those things. Now we're looking at the properties of real numbers. Properties like the commutative property of multiplication, the commutative property of addition. That's where numbers can move around when they add or multiply. We talk about the associative property of addition and the associative property of multiplication. These are very good tools that you would need. So I highly recommend that you look at the second part of Tools for Master Mathematics, a book that we wrote a few years ago. Again, if you have any questions on finding any of these resources, feel free to reach out. I highly recommend that you have a notebook ready so that you can take notes on what you want us to focus on as you go through the concepts. So we've talked about classification of real numbers. We've talked about different types of numbers. It's important to remember, again, your integers, your rational numbers, to understand what a consecutive set of numbers are. That's where you're just going, like, for example, consecutive even numbers would be, if I say starting at 2, 2, 4, 6, 8. That's just the next number in line, consecutive. It's important to know that irrational numbers do not repeat, like they cannot be expressed as a ratio. So the square root of a prime number, for example, is irrational, but rational numbers repeat.